Alright, hey guys, welcome back to another video. Today we'll be focusing on linear law. I have compiled like 4 challenging questions, and yeah, as usual, I hope you guys try to solve it first before looking at the solution. This way, the solutions or like the logic behind the problem sticks easier to your memory. Alright, without further ado, let's start with number 1. So number 1, we have a graph is drawn where ln y plus 2 is plotted against ln x plus 1, and the line passes through 2, 3 and 6, 5. Express y in terms of x. Alright, so usually the thing that I would like to do first would be this. Like I put this like a capital Y is equals to m times capital X plus c. Right? And since 2 coordinates are given, we can easily find m. M would be equals to 5 minus 3 divided by 6 minus 2, which is equals to 1 over 2. Yeah? And with that being said, we can also find c, right? So if we just sub in the values, we have 0.5 times 3 is equals to, c is equals to 2. And therefore, c, oh wait, I think I made a mistake. My apologies. My bad. So we have 3 is equals to 0.5 times 2 plus c. And c therefore is also equal to 2. Okay. With that being said, we can then input the values where since we have already got an m and c, so we have ln y plus 2 is equals to 1 over 2 ln x plus 1 plus 2. Okay, notice like if we apply logarithmic law, right, we can bring this 1 over 2 to the power here, so we have ln square root x plus 1, because something to the power of 0.5 is the square root itself, and we have here plus 2, right? Hence, since we know ln, natural logarithm, is to the base of e, we can raise everything here. So we have e to the power of ln x plus square of x plus 1, square root of x plus 1, yep, plus 2 is equals to y plus 2. Right? And here we can separate this, applying the law of indices. We have ln x plus 1 times e to the power of 2 is equals to y plus 2. Right? And hence, here we have e carried to the power of ln, and therefore we can just cancel it out. So we have square root x plus 1 times e squared minus 2 equals to y. And there we have solved question number 1. Okay, moving on to question number 2. Alright, for question number 2, we have sketched the graph of y equals to e to the power of x plus 2 and state the equation of a straight line that can be drawn to solve the equation. X plus 2 is equals to ln x plus 1 minus ln 2. Alright, so let's first draw the sketch. We have here, we have y, and then we have here x. Always remember to label, as if you do not, you'll be deducted points. Okay, so first of all, I think the most obvious one would be to find the y-intercept. And since the y-intercept, the x is equals to 0, here the y-intercept would be e squared. And hence, I can predict that the shape will be something like this. Since it's exponential, it will gradually go up. It should be smoother than that. Should be definitely smoother than that. Should be like some sort of curve going up. But notice something, the most important thing about this sketch will be the y-intercept, as well as one feature will be that it will never touch the x-intercept. Yeah, it will never be able to touch the x-axis, not the x-intercept. Because if you realize, if we have a number raised to any power, it can never be negative. Yeah? So like 2 to the power of negative 2, it's not a negative number. Yeah, it's actually a fraction. Yeah? So realize that e to the power of x plus 2 will never reach the x-intercept, as it can never be 0 or even a negative number. So it will always seem to touch the x-axis but will never touch it. Right? Okay. Alright, so let's move on to the second part of the equation. State the equation of a straight line that can be drawn to solve the equation. X plus 2 is equals to ln x plus 1 minus ln 2. Alright, since it's in the same question, definitely there has a link to y equals to e to the power of x plus 2, but we don't know yet, so let's just simplify the expression. So this is minus, we can turn it to division, so we have ln x plus 1 over 2. And doing just now what we did, we have e to the power of x plus 2 will be equals to x plus 1 over 2. Yeah, and notice that e to the power of x plus 2 is equals to y itself. So right here, we have y equals to x plus 1 over 2. But this is kind of ambiguous. We don't know which one is m, we don't know which one is c. It's not clear, right? If we write this as our answer, it will still be correct. But it is much better if we can write it in this form where y equals to 1 over 2x plus 1 over 2. Here we can clearly see which one is the m and which one is the c. And with that, we have solved question number 2. Alright, moving on to question number 3. Alright, moving into question number 3. So here we seem to have like to draw the graph of an absolute equation. So we have y is equals to the absolute of 3x minus 2. Right, and so what I would like to do here normally will be to have like a table of values. So we have x and y, right? And instead of directly absolute it, as in like directly turning a non-positive number to be positive, I would like to graph it as it. I would like to like input the value as it is first, and we'll see like it makes the manipulation a lot easier later on. So you have -1 will be -5, 0 will be -2, 1 will be 1, and 2 will be 4. Alright, so let us graph it out. So we have the x-axis, it's a bit too short. The y-axis, then we have x, and then we have y, right? I'm not going to put the values in, that will be a bit too time consuming, so I'm just going to approximate. So -1, -5 will be somewhere here, 0, -2 will be somewhere here, 1, 1 will be somewhere here, and 2, 4 will be somewhere here. Yeah, and since we want to absolute it, we're supposed to turn all non-positive numbers to positive. So here we will have to reflect it at the x-axis. So 0, -2 will be 0, 2, and then 1, -5 will be 1, 5. Right, and then if we graph it, it will look something like this. Yeah. And definitely not straight as this. Yeah, but it's just a sketch. Okay, so we will have like a V shape. And right now the question will be, hence state the corresponding range of y. And so y obviously would be 0. Right. Notice where actually, if we are to take the original table of values, the range of y would be -5 is to 4. But since we flip all the values to be positive, like as in like non-negative, because actually 0 is actually also included, right? This means that all values of y will be greater than or equal to 0. But notice that the maximum value is no longer 4, but 5, because -5, if we flip it to become positive, it will be 5. Alright, okay. So hence, find the range of values of c, where the absolute of 3x minus 2 is equals to 3x plus c has only one solution. Right. So the first thing to realize here is 3x minus 2, the absolute of it is equals to y itself. So we have y is equals to 3x plus c. And it only wants us to find one solution, so we know that it will be somewhere like this, and also like this, right? Okay, so the first thing to realize is 3 is the gradient, and c is unknown, right? And so if we take this coordinate right here, which is 1, 5, -1, 5, we have 5 equals to 3 times -1 plus c. Therefore, c is equals to 8. The second one will be taking the coordinate for the y-intercept, and since that's unknown, we can solve it right now, right? So we have 0 is equals to 3x minus 2. Technically speaking, if we were to solve it for a non-zero value, we will have to square it first, but 0 squared is just 0, so it does not need to be divided with. So we have 0 is equals to 3x minus 2, and hence x is equals to 2 by 3 and y equals to 0. So for the second value, we have 0 equals to 3 times 2 by 3 plus c, and c is therefore -2. Therefore, the range of values will be negative 2, C, or in other words, C is greater than negative 2, but less than or equal to 8. And with that, we have solved number 3. Alright, so for the last question, we have sketched a graph of y equals to 3 ln x plus 1, and therefore state a suitable line equation that can help solve x plus 1 times e to the power of 1 over 3x plus 1 is equals to e squared. Alright, so first of all, let's draw the too small. Let's draw the Cartesian plane out. We have y here, and we have x here. Alright, so first thing to solve obviously is the y-intercept. And so, if x is 0, let me take my calculator. If x is 0, the y-intercept will be 0 as well. And so the next thing we want to know is, this is similar to the question where we have to graph e to the power of x plus 2. There's a limit where we can't reach. And here, there's really no method where we can just directly say like, oh, this can help us determine like where the graph should never meet or something like that. It really comes down to logic and our understanding of the topics. Here we know that a logarithm, like the inside of a logarithm, which is the x plus 1 in this case, can never be 0. Oh wait, not can never be 0. It can never be 0 and below. So therefore, it cannot be 0 or a negative number. It needs to be always positive. Right? So if we have here x plus 1 is equals to 0. So x, therefore, may not be negative 1. Right? And so if we graph it, it would look something like this. Right? And it will always seem like as if it's always touch 0, but it will never ever touch negative. I mean, not 0. It will always seem like it will touch negative 1, but it will never ever touch negative 1, because if you actually input it into your calculator, negative 1 plus 1 will be 0, and the log or ln of a 0 will always give you math error. Right? So in this case, let's solve the latter part of the question. So we have x plus 1 times e to the power of 1 over 3x plus 1 is equals to e squared. Right? And so here we can definitely now say that x plus 1, we can move this one into divide, so we have e squared over e to the power of 1 over 3x plus 1. And here we just need to apply the laws of indices. So we have x plus 1 is equals to, let me see, e to the power of 1 minus 1 over 3x. Therefore, ln x plus 1 is equals to 1 minus 1 over 3x. And here, if we times everything by 3 to eliminate the fractions, because fractions are the worst, we have 3 ln x plus 1 is equals to 3 minus x. And so we have y equals to 3 minus x, because 3 ln x plus 1 is equals to y itself. And yep, that is it for today's session on linear law and a bit on absolute and exponential functions as well. As always, if you have any questions, feel free to leave them down in the comment section below. All the sources will be cited down below as well. And there's this website that I've been really into these days that provides great tips and notes on IGCSE, like the IGCSE syllables, particularly on like math and science. And so yeah, feel free to check it out. Until next time, thank you for watching.